Hi folks, this is Mr. Woodward here to talk about common misconceptions that students have about electric current. And to help clear up some of those misconceptions, I've got a simulation here that shows a circuit with some wires, a light fixture, a battery, and a switch. And the first thing that comes to mind when a lot of people ask questions about current is, how do you imagine current? What do you view or foresee is happening inside of wires? And so this simulation actually allows us to show the electrons in some wires. So if I click this, I can see that there are the electrons. One thing that this points out is that the electrons are already in the wires before I do anything. They're not created by the battery, they're not coming from outside, they're already in the wires. And that's because those electrons are making up the atoms of which the wires are made. So what do we mean when we say electric current? We're talking about the flow of electrons, and right now there's no flow, so there's no current. What I would have to do to make the current or make the electrons flow is to close this switch. And so if I flip the switch here, now I've closed the gap and electrons can start to flow. We measure current similar to how we would measure the flow of traffic. If you could stand at one edge of a street and count cars as they pass by, you would say that the traffic is flowing at 30 cars per minute or 100 cars per hour. So this way of measuring traffic flow is very similar to the way that we measure the flow of electrons. And we measure it by counting coulombs passing a point every second. And we call 1 coulomb per second an amp. That's the rate at which charges flow. I can, of course, make the current stop if I open the switch. And this helps us to see that a switch is merely a place that opens or closes a circuit. So a switch turns lights on or off by simply creating a gap in the circuit. So like I said, the electrons are already in the wires, and they're simply recycled around the circuit. No electrons are added, no electrons are lost. Now, a lot of people think that the electrons move at the speed of light. They do not. They actually move relatively slowly around the circuit. What does move very fast, though, and the reasons why when you flip a switch the lights turn on immediately, is this wave of collisions of electrons. And so let me show that. Pay attention to the light fixture here. As soon as I close the switch, there's a wave of collisions of electrons that moves around, and when that wave reaches the light fixture, the lights turn on. I'm going to show that one more time by actually clicking the Show Signal arrow, which will help us to see that wave of electron collisions with a little arrow. And take a look at it now. There's that wave going around. As soon as it passes the light fixture, the lights turn on. So it's not the speed of the electrons that's really fast, it's the speed of the signal that's really fast in a circuit. Finally, this battery over here is simply an electron pump. It doesn't create electrons, it doesn't provide electrons, it just provides a difference in voltage that gives those electrons energy to move. I hope that this simulation has been helpful to you in clearing up some of your misconceptions about how electrons flow and electric current in a circuit, and that this will help you continue to study electricity in the future.